Now let's understand a bit more about the mechanics of working with Hive. As mentioned in previous movies, Hive includes HQL, which is a SQL-like query which will generate MapReduce code. Specifically, it'll generate one or more MapReduce jobs. And this is actually important in understanding the overhead in the implementation of Hive queries. Hive was developed at Facebook, and Facebook still has some good documentation that they've made public around optimization of Hive queries. So if you've got a very large production implementation, that's a good source of information about Hive queries. Hive allows you to use HQL, which is highly but not totally ANSI SQL compliant. And as you become a more advanced user, it will become important for you to understand which features of the SQL language are supported and which aren't. Now, the Hive community, the binaries are open source, and there are many, many contributors, and they are working towards compatibility with ANSI SQL, and you'll see in subsequent slide here how much progress they've made. So one of the aspects of working with Hive is continuing to follow up on the releases because you'll get more functionality. It's a really active community that's making frequent contributions to the libraries. And I'll remind you again, because it's very common when you show business users Hive that it's an important part of their education to explain to them that the underlying process is batch and not interactive so that they have appropriate expectations around how quickly the query will return data. Now, because it's batch, there are some newer libraries that we'll be looking at in subsequent movies that actually make use of the memory of the machines of the Hadoop cluster that can return the information more quickly. So sometimes you'll want to use a Hive query, and sometimes you'll want to use some of these newer libraries. They include libraries like Impala for Cloudera, for example, which make use of memory to get a quicker return on a SQL-like query. And we'll see this when we work with the Hue interface later in this movie. It's really important to understand which library you're using so that people who are actually writing the queries have appropriate expectations. Hive is most often used in conjunction with HBase. Another way to think of HBase is to define a schema on read, because very often the source for the HBase tables is your HDFS file system, and you create tables out of there. So I'm going to show you what that looks like next. So very frequently you use the create table statement and you just define the columns. This is just a simplified version. And then you run a select from that table against it. So it really provides a nice level of abstraction that makes the data in your Hadoop cluster much more accessible and usable to a broader number of people because, of course, the ANSI SQL language has been around for many, many years, 10, 20 years. And so there's a big base of people that understand that as compared to the amount of people who are able to write a more lower-level MapReduce process in Java. So this is a pretty good summary of the state of Hive as of this recording. So you can see that we have Hive versions by color. We have light green, dark green, and blue. And we can see that we have the compatibility of first the Hive SQL data types on the left side. You can see that the main data types are all compatible. The newest one is the compatibility of decimal. You can see that data types that we're used to in the relational world, like date, aren't yet supported. So again, you have to do a little bit more work in a Hive query to have time awareness, if you will. And then over on the right, we have some specifics about Hive SQL semantics. So you can see that the most common ANSI SQL statements, such as group by, order by, the left, right, and full on outer join are supported. However, I will caution you that the join implementation is very different on a Hadoop cluster than it is in a relational database and can have substantial performance overhead. So even though you can perform it, you want to really test that with subsets of your data before you release that out into the wild. See that in this particular implementation, the ANSI SQL statements that are around intersect, except, union, distinct are not yet supported. Subqueries and having are not yet supported. So there's some common ANSI SQL that's not yet supported. And again, if you're going to be implementing Hive in a substantial way in your production environment, you're going to want to really dive down and make sure that you understand the differences between your base of knowledge, which is ANSI SQL, and what's supported in the particular implementation of HQL that you're working with. So more on the mechanics of working with Hive. You have to make sure that the Hive service is actually started on your particular cluster. Again, when you use the commercial distributions like Cloudera, it'll be turned on by default. There's another aspect of working with Hive that's in the newer versions. It's around this concept called the meta store. So the metastore stores the metadata for Hive tables in a database, and that database can be embedded, local, or remote. And there's a lot of guidance about how to set up the metastore that's particular to the specific vendor distributions. So again, if you're going to be working with Hive, you're going to want to make sure and set up the metadata in the most optimal way for your particular situation. When you're testing, you can just use the embedded, I think it's a Darby database for Cloudera, for example, small and lightweight. But when you go into production, you really want to have a consideration of where you want to put this so that it's most accessible. And in some cases, you want to have it highly available. There is an enhancement to the most current edition of Hive called the Schema tool, and it allows you to work offline in terms of schema manipulation for your Metastore database, which is a feature that a lot of customers wanted. So I just wanted to call that out here. And again, this table compares working with, for example, MySQL, which of course is a relational database, and it compares it with HQL. And you can see it's basically the same in terms of working with the metadata. But again, any of these ecosystems are works in progress. So this is current as of this recording. You want to always verify for your particular vendor, for your particular version, how you access the metadata, which SQL-like statements and in what format are going to work for you. It's just really best to look up the documentation. This is just based on my practical experience of having a deep background in ANSI SQL. And if you just kind of guess, you'll end up being frustrated. It's better to just look up what are the limits and then kind of go from there.